Welcome to The Explainer. Today, we're diving deep into what is, without a doubt, the biggest technological power struggle of the decade, the war for AI compute.
For well over a decade, one company, NVIDIA, has basically ruled a kingdom of immense value. I mean, they didn't just sell chips. They built the very foundation of the AI revolution. It created this world where, if you wanted serious AI power, you bought NVIDIA, period. There just wasn't another game in town.
And that kingdom? Yeah, it's absolutely massive. We're talking about a global AI hardware market that's projected to blow past $400 billion by the end of this decade. And for years, NVIDIA has had a stranglehold on over 90% of it. Think about that. 90%.
But that monopoly, it has just run into its first real threat. A huge new alliance is forming, and it's challenging the very foundation of NVIDIA's dominance. This isn't just a small skirmish. It's a signal that the entire AI supply chain could be about to get a major shakeup.
Okay, so to really get a handle on the scale of this new challenge, we first have to appreciate the fortress it's trying to storm. Let's break down how this one company got so unbelievably dominant in the first place. NVIDIA's power really comes down to three pillars that have been, until now, pretty much impenetrable. First, you've got their incredibly versatile hardware. Their GPUs can handle just about any task you throw at them. Second, there's this massive software moat called CUDA. It's become the universal language for AI developers, you know? And third, they have strategic control over the whole supply chain, which lets them keep things scarce and prices high.
So, if NVIDIA's fortress is so strong, why on earth would anyone even try to challenge it? Well, as you're about to see, it all boils down to two things that are absolutely critical for the tech giants buying these chips: cost and control.
And that brings us to this key idea, vendor lock-in. Basically, tech giants like Meta, who need billions of dollars worth of chips, are absolutely desperate to escape being stuck with just one supplier. Nobody wants to be locked in and forced to pay what everyone in the industry calls the NVIDIA tax. And believe me, it is painful. So this desperation is what led to this really calculated three-way alliance. You've got Meta, who needs a mind-boggling amount of chips to power its platforms for billions of users. Then you have Google, who's been quietly perfecting its own custom AI chip, the TPU, for a decade. And finally, you have Oracle, who comes in as a sort of Switzerland of cloud computing, providing the neutral territory to connect it all together.
And this timeline right here shows Meta's really elegant two-phase plan to break free. Phase 1, which is happening right now through 2026, is what you could call a rental bridge. They're going to lease a ton of Google's newest TPUs to just test them out at scale. But Phase 2, kicking off in 2027, that's the real game changer. Meta plans to buy the chips themselves, install them in their own data centers, and get total control.
All right, this whole alliance isn't just about business deals, though. It's really made possible by a fundamental difference in the tech itself. So let's get down to the core of this battle: GPU versus TPU. It's really a tale of two totally different design philosophies. The best way to think about the difference here is a generalist tool versus a specialized one. The NVIDIA GPU, that's your Swiss Army knife. It's super versatile, it's powerful, it can do pretty much anything from gaming to AI. Now, the Google TPU, that's like a specialized chef's knife. It was designed from the ground up to do one and only one thing with insane efficiency: run the math for neural networks.
Okay, and what's really fascinating is how their internal architectures, their guts, actually solve problems. Think of a GPU as constantly running to the fridge. For every single calculation, it has to go fetch data from memory, which wastes a ton of time and energy. The TPU, on the other hand, uses something called a systolic array. It's more like an assembly line. Data just flows through the chip in a steady rhythm, which means way, way fewer trips to that memory fridge. And that specialized design is really paying off. I mean, for the first time ever, look at these raw specs. Google's latest chip, Ironwood, is basically matching NVIDIA's top-of-the-line Blackwell chip on key things like performance and, this is a big one, memory. That's huge because it completely neutralizes one of NVIDIA's biggest advantages from the past. But here's where things get really crazy: scale. It's not even a competition. An NVIDIA system can connect, 72 GPUs together in a single rack? Google, using these advanced optical switches, can link over 9,000 TPUs into one single massive supercomputer. That is over 100 times more chips all working together as one brain. But this war isn't just about raw hardware specs. Not at all. The real battles are being fought on two other fronts that are just as important: software and economics.
So NVIDIA's greatest weapon, honestly, is its software platform, CUDA. They've got a 15-year head start, and it has pretty much locked every developer in. But Google and Meta are trying to get around that with this really smart tool called PyTorch XLA. Think of it like an intelligent translator. It lets developers take the code they already have and run it on TPUs with just a few small changes. It's basically an attempt to build a bridge right over NVIDIA's strongest defensive moat. And then you look at the economics, and the difference is just, whoa. NVIDIA sells its chips at these insane gross margins, over 75%. Let me put it this way. For every $100 a company like Meta spends, 75 of those dollars are pure profit for NVIDIA. That is the NVIDIA tax that everyone is so desperate to stop paying. Google, on the other hand, makes its TPUs pretty much at cost. And when you combine that with their more efficient architecture, what you get is a chip that delivers 2 to 3 times better performance for every single watt of electricity you pump into it. Now, for a giant data center, that's not just a small thing. That translates into millions, tens of millions of dollars in electricity savings every single year. So, what does this all mean for the future of AI? Where is this all heading? Well, it means the market isn't a one-way street anymore. What we're seeing is the creation of a brand new 2-lane highway for AI. Yet the AI world is really splitting into 2 distinct lanes. In lane 1, you have Discovery AI. Think of this as the Ferrari lane. NVIDIA will probably continue to be the king here, the premium, flexible choice for researchers doing R&D and building brand new experimental models. But in lane 2, you have Factory AI, and this is the freight train lane. Google is positioning its TPUs to be that industrial-scale, super cost-effective workhorse for when you need to deploy a proven model to billions and billions of users. So what are the big takeaways here? Let's boil it all down. First, the NVIDIA monopoly. That monoculture we talked about, it's finally being challenged for real. Second, Google's TPUs are a genuinely credible alternative, both in raw power and at massive scale. Third, the real threat to NVIDIA isn't that they're going to go out of business, not at all. It's that their sky-high profit margins are about to get a serious reality check. And maybe most importantly, all this competition, it's a huge win for everyone else, driving down costs and speeding up innovation. Which really brings us to the final question, right? In this clash of titans, who's the real winner? And the answer isn't really about one company winning and another losing. It's about the market finally having a choice. Because when these giants compete, the real winner is the entire AI industry. And that means cheaper, faster, and more accessible intelligence for everyone. And yeah, by extension, for all of us.